So thank you all for joining me to talk about the research going on in LabX and VRL. I'm Dr. Ph.D. Sawyer. I'm an assistant professor in industrial engineering and management systems. And today, here we go. I'm going to be talking a little bit about my background and what my lab is currently working on. So before coming to UCF, I was a contractor with the US Air Force and also supported by them. I did my postdoctoral studies at MIT, where I led pre-competitive industry consortia. The awards for my work are generally in the area of cybersecurity, but what I really do is information science, and I talk about how information moves. In fact, in that area, I have a 2018 US Air Force YIP award. I teach probability and statistics and human-computer interaction. And I have two labs, one of which I've just started in collaboration with Adobe, and we'll talk about that. So LabX is the lab that I started upon coming to UCF, really with the goal of optimizing autonomy brain information throughput. And we really have four ways that we approach this. One is through human factors engineering, building models of humans that can be used by algorithmic processes that can be baked into autonomy of various types. We also approach it from a neuroengineering angle. We're interested in non-invasive techniques that allow the information from your brain to actually influence autonomous systems you're working with. And actually on the right here, I have a diagram from a closing the loop system that I've worked on previously. Neuroergonomics is doing the same thing, but in closing the loop through design. So rather than having your brain reach out and do something in a system or influence a system, you look at individuals doing things and use that for redesign. And human security encapsulates the fact that whenever you manipulate information streams, whenever you consider the question of throughput, you have to consider security and trade-offs between security and speed. Right now, we work in cybersecurity. We've previously did work in surface transportation, dismounted warfighters, pilots, and we're getting into education questions. We're really rethinking how information moves from human to machine and back. So three projects that might help to understand that within the LabX umbrella. We're looking at moving awareness of human errors directly to autonomy. The idea being that that can then weight an autonomous system. So perhaps have a driver of a large truck have the truck prime the brakes so that when the human responds and presses that brake pedal, there's a faster response. We're really looking at low power strategies for real-time identification. In fact, we're working here on actually adapting statistical techniques rather than the traditional signal processing techniques that have really dominated. We're also looking at security questions. So once you're picking up this type of detailed information from the nervous system, we're really interested in what you can get through a commercial device that's already attached. So there's 2 million people walking around with cochlear implants, which are very closely tied into their peripheral nervous system. And the really interesting question there is what attack surfaces exist when the human becomes a cyber-physical system, something we're very excited about. Finally, from a purely mathematical standpoint, information theory allows you to change the flow of information to create effects. And so we're working with the Air Force on this question of how do you find rhythms and attention that let you time information to help a person succeed or to cause them to fail? So one study that we've gotten a lot of feedback on shows that you can have someone click on a phishing email against their will, or perhaps on the latest email that you got to join the Journal of Autonomous Basket Weaving. If you could be made to click on that without even knowing you did, that would really change the landscape and really gets back to a security question. So let's take a step to my other laboratory, the virtual reading laboratory, just started with Adobe. I've often been interested in reading specifically because when you build interface, the most flexible interface is the written word. And a lot of interface in human-machine interface is composed of words. Glanceable watches or your smartphone or any device really right now has so much functionality that you need to fall back to using the written word. we're working with Adobe to redesign digital reading. New tools, very big data, 1 to 2 orders of magnitude what's ever been collected before, and really try to build what we're calling autonomy for documents. Right now, when you open up a PDF or a web page, it's a passive thing and you're actively looking at it. We'd like it to reach out and meet you halfway, for information to reorganize to your occupation, your context, or your goal. One context we're very interested in are these flight line mechanics you see here, who are using an e-reader on the flight line where traditionally heavy paper manuals have been used. This is a big transition, and it's one that is not without its difficulty. They are standing next to a machine that can and will kill them, and yet they need to be staring away from it at a device. The question is how to make the task go well and also the reading task go well. So some interesting things we've been able to do just in the first little chunk of time that we've been working with Adobe and some other great partners. One is by characterizing which aspects of typography seem to help people. We've been able to tailor you to your best fit in a font and then reflow documents to match you, essentially. And the reading speed gains there are enough that I'm using it in my own PDFs, about 10 pages an hour for the people who are doing best. So if that sounds exciting, I'm working on a little demo to give it to faculty too. It's quite nice. The other really very different and more technical end of this, I would say, is we're working to figure out middle layers mathematically. So on everybody's front slide for these talks, they have their name over a complex background, very common thing in design, and a very common thing in augmented reality. How do you make people able to pick up that textual information against a very complex real-world background? And there we've been able to plot functions that show how various techniques like Gaussian blur, which is used a lot, can be optimally used so that you can preserve as much of the background information as possible while still making the text readable. I should say that that work is in collaboration with another project with Army West Point and the US Air Force Academy, where we're going to be putting it directly into battlefield displays that are used to visualize the battlefield through augmented reality. So we've already found a group that's interested in this, although we think it could be used in a lot of places. So in rethinking how information moves between human and machine, there's really a lot of interesting collaboration, I think, available. I'm really interested in computational human factors, applied neuroscience, sort of novel neural sensing approaches I'd be very interested in. I'm interested in human-agent interaction and information exchange, both in a one-to-one sense, but also in giant end-unit to end-unit systems, right? I'm really interested in novel modeling techniques and tools, vigilant attention, and rare signals. So systems where you must wait a long time to see the signal are something I specialize in terms of the math. I'd be very interested in contexts where that difficult problem arises. Novel HCI and UX design is something I've done quite a lot in the past. How do you visualize data to make a human understand the state of a system? I've done that in a number of sort of what are now not less cutting edge areas. I started in them early, but I'm really interested in strange new things. If you have something that you don't know how to connect to your human, I'd love to talk to you about it. Designing for attention and distraction is something I find very interesting. Patterns of attention, when is the right time to move information to the machine or to the human? In one case for attention and distraction, and the other for power saving and low power systems. And security, which is baked into all of that. How do you keep systems secure while still achieving these goals? I can imagine eye tracking and actigraphy approaches sort of for the web being very useful for this work we're doing with Adobe and e-reading. But here's the thing. I would like to know about your own fascinating intersection. I'm sure that somebody out there thinks you have something interesting. Reach out. The most interesting thing that could come out of this talk is working with somebody who's doing something I never imagined. And so with that, thank you so much for your attention, and I'd be happy to answer any questions.